Hey, it's STEM 2.7. Today we're going to learn how to write formulas with polyatomic ions. I know I talked a little bit about this yesterday. Well, today is the day. We're going to do this. It's going to be pretty easy to do, so don't worry too much. Similar rules as last time. If it's a regular atom and it's the positive, it's the cation, it starts off, or it uses the regular name, just the name, right? The elemental name. If it's an anion and it's just a regular atom, or it's just one single element, it has that "ide" ending. But if they're polyatomic ions, and we know the polyatomic ions because the polyatomic ions are going to be in parentheses like this. Remember, poly, more than one. Atomic, atom, ion with a charge. More than one atom with a charge, and that's what we're looking for. Mr. Arnold puts in parentheses every time to make sure you know where they are. So there we have our first one, that OH there, this SO4, this PO4, this NH4. Those are the polyatomic ions I'm talking about. You're saying, which one of the last two you're talking about, Mr. Arnold? Well, NH4. There we go. So what we're going to do is we're going to use our chart. And the polyatomic ions are on the back of this chart. We passed this chart out before we had to go. But now, hopefully you have it at home. If you don't, I have a copy of this on Schoology. And you know that already because we talked about it yesterday. So let's get at it here. So I'm looking at H. I'm just going to look at my chart right here, right? And remember, the chart looks backwards because of this camera. I'm just using photo booth. I don't know. So H is hydrogen. It's the first one, so it's the positive. It's just the normal name, so it's going to be hydrogen. Whoa, let's change the size of that font. This should work. Maybe it won't. Let's try it one more time. Come on, write for me. Hydrogen. Okay. Hydrogen. Now we're going to look up that OH. Use the back of the chart here. Now we're looking for this. I see it. It's right here. Hydroxide. Okay. Now, if you have this chart, it's probably easier for me just to point and show you where it's at. It's right there. Hydroxide. And it says that is OH minus. So that's OH. So I'm going to write down hydroxide. Hydrogen hydroxide. What do we really have there? HOH, that's really water. But this is a scientific way of saying water when you want to show the polyatomic ion, hydrogen hydroxide. Okay, so that's how we're going to find these things. I'm going to help you find the names. You can do this in slow motion if you need to see later. Magnesium, it's in row 2, column 2. Remember, my table's backwards. Mg's magnesium. Look for SO4, it's on the back. Sulfate, magnesium sulfate. Okay. Same idea. Ba. Barium. PO4. Phosphate. Barium phosphate. And these are the notes I'm filling out, right? You know that, right? Okay, and we have one more here. I'm going to show you, and then I'll turn you loose on your paper that you'll have. I'm trying to make these short. I'm trying to make them right to the point. When the polyatomic ion is the first thing, that means it's the positive. It's the first column. It says +1. There's only a few of them we ever use, and this is the main one, ammonium. NH4 plus is ammonium. Oop. And then that Cl, I had this in my front of my face, and that Cl, of course, is our just a single atom. It's Cl, it's right here, chlorine, right? But it's a negative ion, so we call it chloride. That's it. Okay, that's all there is to it. Do the next section. I'm going to throw 12 of them on there again. Just name them. They're all going to have polyatomic ions. There might even be one with 2 polyatomic ions. All right, hey, have a great day. I'm out of here.